Good evening to everyone. This is Engineer Suraj Singh speaking from Bharat, India, and addressing this talk to all people involved because this is regarding worksheet and something to do with how to work on spreadsheet or Lotus 123 or Microsoft means to deal with data, to deal with formula. I already delivered one talk with a small video today morning which was disconnected. I don't know reason behind that. It was just I wanted to give complete details, but it was just hardly I can say 24 minutes, and I was disappointed really. Still, video and the audio are not working properly. I'm not sure whether it will continue. Still, because video is giving 00 bps and audio is giving 00 bps. I don't know reason behind that. Every day it happens, and already it has passed 1 minute. Yes, now video has come, and audio has also come. So I'm continuing this one. Again, I'm saying if it's not recorded properly, that I am going to talk to you about worksheet, about how to formalize, how to link formulas in this talk. I talked already in previous video, but unfortunately that video was curtailed. It is disconnected, or it was not allowed just for only 20 or little more minutes. I talked to you. I just told about ranges in this. So this Excel sheet, I'm just moving on this sheet, and you'll see that this Excel sheet here. You can just I told you about all the sheet today morning means how it moves. I can just give you another view on this, how it works and how it moves. That's an important point, and you can see how it works at all, and you can see just I want to see this information just immediately. I mean, what is the method there? That's why it's very important. And I say this is there is about more than 50 ranges in this. It depends on how you do that. There are more than 50 ranges. I allow this. I'll show you all those ranges. There are eight stories from one story to eight stories frame analysis in this. I'm going to talk about that little, minutely or elaborately. Depends on if video works. So this I can move fast now. I can see you can see that's how it's working fast, and how ranges work. So this is gone now. Let's go back to home. I'll show you ranges now, and that is in that I think. No, edit links. No, it's not edit links. Okay. I just go to F5. F5 is here. I go to F5. You'll see these ranges. If you see in go to, you can see here all ranges for this file. There can see the 8th story. Copyright this. You see 1 2 3 4 5 6 7 8 like that. All ranges are there, and I want to go to whatever range immediately. For example, I go to this you do two-story method brief, and that is two-story method brief. Then I come back. I take okay. I want to go to somewhere else. Let's say I go somewhere else. I go one story analysis. I go to one story analysis. It's like that. If I say again that I want to go to some other range, let us say quantities, RCC quantity, first story RCC quantities, I'll go there. And if I say okay, I'm here, I want to go to something else. I want to go to three-story RCC, two-story RCFs, three-story RCFs are here. So if I say okay, I now want to go to this two-story notation. So this two-story notations. So I say if I want to go to F5, one-story forces, this one-story forces. If I say I want to go to something else, it is, let us say, two-story results. So this is story results here. I want to go to I say somewhere else. I will go to two-story CG table. So this is two-story CG table, and I say I want to go to for five-story results. So this five-story results, you can see the five-story here. This is five-story results, and if you see, I want to say that I want to go to somewhere else, and this way. This one's this way here, as you can see. Forces. This is that. RCFs. Let's say this is semi-story analysis. Semi-story analysis. Semi-story analysis. You can say this is semi-story analysis. If I say here whatever else, six story results. The results, 6 story results. One story, no, not this method verified, go somewhere else. 8 story results, 8 story results, 8 story results, 8 story results. So what I may say, you can go to wherever you want by this range, and provided your sheet must have range clear, so you must have named them, only then you can go there, otherwise this will not work. Slash 8 story RCFs, I used to RCFs, and these are RCFs for 8 stories. This is how, this way it ranges work. Now this is one part of this. So now what I do, I can say now this is what I wanted to tell you about range, and I think you might understand. Also there are links in this. For example, this is one story link, say this one story link, the 2 story goes to 2 story, and goes to 3 story, goes to 3 story, goes to 4 story, goes to 4 story, goes to 5 story, goes to 5 story, and then 6 story, and then 7 story, and then 8 story. These are linked on same sheet. That's another point. Link on same sheet, and there's no, so we go back home. I go back home, you can say control home. Now same links are shown on everyone, and for the places there is 1 story 5 minus 5b, 1 story 5 base, 1 story 5 everywhere, and where it is not 1 story, this 2 story, you will find 2 story 5a, 2 story 5a, and when there is 3 story, you will find 3 story 5a, 3 story 5a. So this is what it is. So we go back to 1 story here, 1 story, so it's a home here in this case. Now what actually I want to give you, now I said that here you see there are some information here. So of solution I have written theory of structure, analysis of frames, movements and loads, call whatever it is, loads, loads and calculations, and highlighted cells. This is called highlighted cells are editable. These are highlighted cell, editable. For in RCF, this RCF is here, rotation contribution factors we call it, and displacement and movements, etc. Whatever is given written means I'm not interested in that. How to link it, that's important point. Actually what we have done, I have linked, this is, if you see here, just for information, if you see here, what is this? What is 1 story? This is a slab kind, alright. Bay means 1 bay, 2 bay, 3 bay, 4 bay and 5 bay. So this is 5 bay, you can say this is 5 bay. So now what you do, I say this is 1 story, this is the foundation part. This is just, I'm explaining to you what I mean. And this is, you can say, connection, joint here, this is joint with the slab, beam and columns and like that. This is foundation here. Now I have nothing to do here. I have just fill in for this one part of this, and this is for all. Method brief is given here, and all cells uneditable. They get clearly all cells uneditable. This is calculation cells, and also here some rotation control methods given. What does RS means? Rotation, relative stiffness, TS is total stiffness, DF is distribution factor, RCF is rotation contribution factor, WM is load in tons per meter, TM is bending moment in tons meters, and L is span length in meters, FEM is fixed and movements, that is in ton meters, FM is final movements ton meter, DL is direct load on columns, the WLM wind load moment, TM ton meters, and the displacement factor DEF and cantilever, W is load, HR is equal to horizontal reaction. These are notations for this. And here's a method. Here is a method description. Here just for information, this will follow method is applied 3 number cycles to reach final value of moment and loads. Save as file in any name. So that's what the wind loads, projection loads, point loads can be applied conveniently, editing various values in relevant cell. All these edited cells are connected directly to final value separately. Final values shall include these forces algebraically. Number of trials, whatever number of trials can be conducted. Element sectional dimensions can be edited for values of relative stiffness for RCC structures. For hinge the case, apply 3/4 adjustment in relevant rotation relative stiffness column, cell, and enter. For steel structures, substitute relevant stiffness values. For steel structures, substitute relevant stiffness value in RS column cells. Point loads can be considered both at projection or on point load can be considered both at projections and on internal beams. On internal beams, every point load can be taken, and etc. What is given here, you can read that. Whatever number how number of cells can be conducted. Element sectional dimension can be edited for various or values related to stiffness for RC structures. For higher case, apply 3 or 4 adjustment in relevant RS column cells, and for steel structures as given here. Seismic calculations also of the required number of loads can be added. Seismic calculation have been included by applying a percentage of horizontal sway at slab level, exporting bending moment into beam and columns. Wind forces shall be entered 0 with seismic force, and all this just means only for information, and is valid for all cases, all 8 cases. Now this is calculation, then this calculation goes to this one. This calculation after results from that are collected and are taken in this table, in this called result 1. This is result 1, and we call it this some doing technical study, that is for sway, check value of moment of inertia, and all that is a seismic drift. This all engineering, and just for connection purpose, for link purpose, I am trying to show it to you, for nothing else. So, and then there is, it's a center of gravity table for this framing in both directions, and that is vertical and horizontal, and then there is a quantification of RCC, etc. This is what is detailing, and this is detail, common detail for all is one, and this is here, because this is stiffness we are getting here, displacement factors here we are getting, and these are transmitted to here, to this one, and also loads in this would come from here, and this is added load here. This is load 1. You can say loading, intermediate frames, moment calculation, etc. And these are various types of loading and their results. So all this is that. So here you can say up to here, this closes one story. And so how many, you can say how many links are there that you have to understand now, which is very important part, and for that purpose only this video is coming in. So there's no other purpose on this, So this is home now. It's not reaching home. Let's take this home now. What to do now? Now let us say this, we start here, means this diagram, okay, but for example this diagram has to be connected by this. Now what is here? Here B stands for width or breadth, D stands for depth. This is width or breadth or depth. This is L over B. L is there, L is there, L over B is there, and L is here. You can see rotation consider formula for rotation consider factor. I use key 5 to find contents range less than source of the message. Elements are like this, beam, column, element, beam. It depends upon from this. Now we take A naught, B naught. For example, A naught is here, and B naught is here. Like the naming is there, A1, and it's naming only. For that purpose, we can say A naught, B naught means A naught, A1 is column, where both are is column. A naught, B naught is horizontal beam. Then and all these notations are there. Joints are there. So this is A naught joint, A naught, B naught, C naught, D naught, E naught, F naught, A1, B1, like this is A1, B1. This notation is there, Now what we do, that's point. That's point means what why how shall we proceed? That's an important point here. How you have to proceed. That's very important point. What we do now, you see, we know what size of beam, what size of column we are going to put in there. That's the important part. And I say that's the important part, beams and columns in this case. And we cannot simply jump away. You understand? And only engineers can do it. Those are design engineers and those are analytical engineers. So this you can consider as a form. Here also, these are A naught, B naught, and beam, and this also columns. A naught, A1, B naught, B1, C naught, D1, like this. These are joint columns. Means column means you can see here. For example, this is 5A. So 1 column, 2 column, 3 column, 4 column, 5 columns, and 6 column here. So these columns will come here because, and this column, and this is here slab and beam, slab and beam, slab and beam, slab, like that. So what I say, we connect it to that one. How? That's fine. You have to put dimensions of beam and column here. Here these are dimensions, whatever is there. In green color that's shown, you have to pull yourself. You have to decide yourself. I'm not going to do whatever you take. You have to fill in there. Then these are all formula. Length you have to enter. Length of member. For example, this is length of beam. This is height of column. So whatever member is there, we have to have the dimension of that length, vertical, horizontal. So what this dimension you have to enter. Nobody, you have to decide according to your design. And then we have to say R. So what we say, L over V, we have to find the first of all length over V. B is available here and L is available here. That's L. So you can find formula L over B, and you have to see how it is coming. It will come and you can link them automatically. Now how to link them? That's why here there is no link. This is no link. This is no link. This is no link. We can link them if you wish, or we should keep left this out. But here L over B, C, G10 over A10. You see, where is G10? G is this is length, G over G10 over A10. A10 is this. So this is automatically, when you link this, everything will be linked. All this is, where there is no grain, there is no highlight, that's completely length. And here elements name or beam have written here. So you have to write that. Nobody can write for you because this is not calculation. Joint aspects are there and members are there. Lengths we have entered already, and we can change this length depending on requirement. If you want to link them, you can link, for example, is 6 meter, and here it is length. It is 4. I want same one, so I can say this G11. G11, you can say here 6. It depends upon you. You want to fill yourself or you want to link that. Now that's one part of this. Now the work starts at relative stiffness coefficient, then relative stiffness, and then relative total stiffness. This is a factor, and RCF, rotation continuity. There's a formula for that coefficient. Now this is A10. A10 is here. B width. B D square. Whereas D is here. B10. A10 and B10. A10 and B10. A10 and B10. BD square. BD cube. BD cube over 12. This is formula. This formula is here. Same way this formula is here. This all formula. We all this formula is there. So this completely for you cannot do anything here. Rotation, relative stiffness. Now this coefficient. So we have stiffness here. This H10. This H10 is divided by G10, and this is G10 length. We have to divide this value by 10. So RS comes, and all is RS here. You have to see all RS is here. So this you can see here, these are all links here, and I'm not joking. These links here, this links here, this links here, and here even the links are here everywhere. And also total stiffness. Now total stiffness. So what we have joined these two members here, so we can say total stiffness. Sum of I10, A10. This is I. This is I this 10 and this one. So this is I sum I10, 10. Same thing is here. Then same thing here. There are three members. So there is some 13. These are all three. All three sum up and we get this all three same. Like this everywhere it is. I then also you can say it is linked one. Is linked one. So now we have done links of RS coefficient. We have done RS and now total stiffness. Now distribution factor. That's point. Now let's say what this factor is. I10. This is I10. This is I10 relative stiffness over J10 over total strength. Relative strength, this divided by this. That's what what is this? Total strength, sum of I10 is also. So this we divided by this we divided by this, and we get this answer. And this is for all, it works for everywhere. Same thing, where 2 members are there, 3 members or 4 or whatever number of members are there, we have to do that. And then is the rotation contribution factor. That's formula we have to see. Distribution factor rotation contribution is half, minus half of this value. This is according to theory. Minus half of K10. So we get RCF. Now this RCF shall go here. You remember that. First of all, let's say RCF is, so we know RCF. You cannot change it. RCF is automatically there. Now we are going to displacement factors. What is displacement factor here? Column A, this A naught, A1 like this, B naught, B1, C naught. This is all like this. So we say member is A1 naught, A1. Then B naught, B1, B like that. C naught, C1, D naught, D1, E1, and length is there. When both signs are same, A, B, B, C, C, D, D, in this case that's column, and when different A, B, B, that's beam. So length is 4 meter. We can't change because we have to take from here. This length is clearly saying G11 is G11, so G is 11. So we have to link here all these from here. So we have the RS coefficient here we have, and we have RS coefficient here. If we link from here, you see it is H11. Same coefficient comes here. RS coefficient also comes here. That is Q10 or P10. And what is Q10? This is Q10 as a coefficient here, and P10. P10 you can say P10 is here length. So we get RS, then we get total stiffness also we get here. R10, R15. This is total R10. This is R10 here and R15 here. So this total stiffness comes. And then distribution factors, we get this link RS over S10. RS over S10 we get the distribution factor, and then this distribution factor minus 302 into this value. So this we do for everyone. For whatever stories are there, we have to do that displacement factor. This is engineering term, but I'm just telling you link. And there's a problem, there's a point here. I'm working to find center of gravity this way, and this way means horizontally and vertically. This is in this case horizontal CG, and this vertical direct close, and there's displacement factor. This is just for adjustment purpose. I put here only. Now move further. This what I do. Yeah, this table has links from rotation contribution. This has we have here rotation contribution factors and displacement factors. First we will look rotation contribution factors and displacement factors. So here this is what? This is x13 plus AB13. Before that, we will talk this later. This point, for example, L10. Where's L10? That's L10 is here. This is L10. L10. This is L10. So this value is 0.5 K. Here value is this, but this way we have to bring here this value. L10 we have to bring here. This is rotation contribution factor, because this will rotate. This will rotate like this joint, and these joints will rotate also. So that's one. This is rotation contribution factor here. That one is linked here. Similarly, this one is linked to L11. This is L11 linked one. Same way we link here. There's no member, so it is 0, and there's a member here we linked, and there's a member, so it is 0. That's one point. Similarly, here we see B naught A1. There's one B naught A1. This is so L13 it is. So this is L13. This is L13. L13 here. If you want to see that, you can see also that one is D, and also it is A. This A. So I just reduce this little one, so you can see that clearly. Here is this. So I said this is L13. So L13, L11, 12. This is the 0.143. L13. This is L13. L13 here. This is this. So this is here RCF. So this is RCF here. L13. Here it is 0. Here it is L15. L15 here it is it is L14. So this joint has 3. Here 2 because this is AND joint. So this is having 1, 2, 3. 3 values of that of these RCFs. These RCFs have been shifted. Have been shifted here. Shifted, I mean not shifted, actually length here. these values. So if you go further, you'll find all these are similarly linked like this. This is where link works, Now here, for example, this is another joint. You see here it is L32, as we said from there, L32. You can say this L32 here, L32, L32, L32. This is 30, 31, 32, 32. Yes, it's there. L32, and this is even A naught. So this is L32. This is here, and even A naught. Like that, this is another one here, L33, and here L34. Similarly, here we have 4 in this joint, and we link like that. Here, we start here, say L37, it is L36, is L39, is L38. Similarly, here we can say L42, L41, L44, L43, and also here I'm just trying to tell you L47, L46, L49, L40. Then you see these notations, they will find same member. Here it is L52, it's L51, it's L54, it's L53, and it is here L57, L56, 0, and here is L58. So this is joint. So and also we have to do displacement factors, as we said, and this is displacement factor here. You can say displacement factors are here, and this is here. This is U10, U11, U12, U13, U14, and this is U15. And let's see what the U here. This is U. This is displacement factor here. All same. So this is linked to this, this table. So we have linked here. For one part of link is over. This is for rotation condition. So now another link is this. Say here, this joint. This is here is X13 plus AB13. Now what is X13 and AB13? We have to understand. X here we say X is X13 is here. X13 is here. This is there. X13. Maybe some load which we have to take from that table. So this is here X13. You can say we are taking here X13 plus X13 is 0 here, no problem. But tell me anything when we add value AB13. This is AB13. This is that. So this is result of moments. Moments we call in our engineering a force. It's a force here. So this value and this value, and it's taking sum of these two values. So this is some minus 7.94 is here, and if you go here it is, we are taking here, you can say AE13 plus AI13. So where is AE13? This is AE13 here, and AI13 is here. So this is that, this plus this sum. Similarly, we can say if you go this way, we'll see these links, that is here AL13, this is AL13 and AP13. So this is that force. Also here you will see AS13 and AW13, and like that here, like that here. So at every joint we correlate these lengths, which are now after this correlation we have to this information we have. For example, here it is as for 8.8 X25, here is X25 and AB25, like that. Here also we have values, this value, that is AE25, A25, and AI this value. So at every joint you have force link, a calculation of force, from where this force comes at this point. Now from where this force is coming, from where this force is coming, that we have to see in force. Now we'll go to forces, and forces means if I go F5, let us say I say F5, first story this is, and first story forces is here. So we go to forces, this is forces table. So we, by using range, we can go there. That's the same for the point. You understand, this is the force. You can see that force now. We go back to sheet and see this forces there. A, these are all loads I've seen, and what I've done, I did loads here. I said what load is, it depends on about when load link is there. If you want to use that loading, or you calculate this. So let's say we lose a load link here, so you can say maybe the file is missing somewhere. I'm not sure. There's link file or link file here. Let us say yes, this is correct ones to follow. So it's coming. Yeah, it's coming. This is load file. Let us see. You can see in this no. So this is load file. You know, this is load file. We can use this load file. This also Excel file has files open. Load distribution chart on square, rectangular, base, on slab. So what is it? There are different types of loads in this. You select yourself and you do design work. Means your choice is there. There's a complete system is given, and it's up to you. And it's also linked. You know, it's not free. You can link to this file. All these are values here. The values is linked here. This is linked. All results are linked here. Various results or formulas are here. So this is a link. So you can say in that connection, this is that file. This is a loading area. This can be linked here, and at end what is that? This is linked to, you know, for example, B95. So B95 is here. B95 is here. So this is linked here, and this is from B96 and load links. You know, these values we get from load links or whatever, and then we see here you know, this is ends. Edit loads here. This all loads we edit according to members, and here we can say intermediate frame, then moment if it is intermediate there was a level, and members, which members are there, projection is there, cantilever projection is written, and AO projection also cantilever, and AV, you know, all these, you know, the same members, A not B not B not A not, all this BB, you know, this is because it's a beams, and this is fixed one, all are fixed one, and this WM, this is weight. What weight is there? For example, saying 1.53 here, A96, this A96, so I'm taking from here, and all these connections are here. You can see A97, A98, A99, A100, A102, A101, 102, 102, 103, 104, like this. And again another end comes, and there's another cantilever. So that projection is different one. So this is cantilever, other side cantilever. So now we go to this is you know, weight per meter, and this was fixed. This now weight per meter. We are taking weight per meter here, and you see here is span. What span is it? This 6, for example, G10 is saying G10. So G is now we have, is there G10, G13. All these values are there. If you go to there, you will see G10, for example. This is G10. This is the same span which is here. Whatever span is here, we have to take here. So that's the linked one. All these are linked one, and these are unlinked one. Now this is basic information. We have load here, and we have span here. So we can say there are different types of moments. Is WL square 8, that's one formula. WL square over 12 is another formula. WL square over 24 is one more. WL square 16 is another. WL square 2, WL4. Different types of formula. This is called UDL, means uniformly distributed load. Moment calculations template is UDL, and this is different one, WL4, and this is something point load like that. So this is what I say. This is basic. Maybe you may not understand this is engineering, but I'm not too worried about that. But my worry is that it should be linking. Link is important here. We should understand linking method here, and that's what we are trying to understand. I'm not giving you something engineering here. I'm giving you how to engineer using Excel or Lotus or whatever you have. That's what you have to do it here. So again, there is some problem in video. I think 00 bps showing an audio 00 bps. If I continue this, maybe this is not recorded, so I have to wait for a couple of moments, because video 0 means it may not enter, my voice may not enter, my audio may not enter. So let us see how it works. It's still 34 minutes over, but it's not showing anything. So let me see how it works. That's a great one, and because this link is very long, it's not finished. I want to tell you more about this. Let it come back. 0 bps is come on, give me signals. Why signals are cut off? I don't know. I have to wait, I think, because there's no meaning of this. Maybe you can't get my voice. In this case, when there's no signal, no audio signal, no video signal. Opposite, saying, what do you mean by opposite? I don't know what's opposite here, what opposite, audio, opposite, I don't know. And actions, event logs, what event log is saying, let me see. What event log is saying, it is given a long table, warning, warning, and warning. Warning, 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 I don't know what's what. It says Facebook has not received video signals from video, so for some time check that. And Facebook has not received video signal from video source, or sometimes check that the connectivity between video source and Facebook is sufficient for source resolution and byte rate. So let them say, means they're saying something. So let us see if signals are back, or I have to stop video here, because without signals 35 minutes are running, but I'm not getting back. Oh, it's come back, so I continue. So I say come back, so I continue with this. So I say here, I say WL square over 8. I use this formula, for example. Span is already there, you have seen. Span is there now. This is real location, you have to say. Otherwise I'm saying no and no, because now it is here. This is FG. Here is, F96. F is a 96. So F is here. F96. This is this is ton per meter. This is ton per meter. So this load, you can say 1.5. So here in this formula, this is here. This is load. F96 is here. This W, and this is G96. G is a span, G96. That's square. This formula is WL square over 8. So this is W. This is W here. Oh my God. This is W. This is G96, and this is G96. This is length, G96. This is length here. So formula says here W is L square. This sign of square. I don't know what it's called, and over 8. So this result comes, and this is for all cells. Similarly, same thing, because I'm saying so this is linking. Then the other one is WL square over 12. So that's like this, WL square over 12. Then that is same thing. So it is for everyone, all like this, And then it is WL square over 24. Same thing is here, 24. It's for all, you see, not only for that one. So same. The WL square 16 here. The WL square 16. WL square 2. This WL square 2. And then WL over 4. This is for different cases. We will link from them to that one. That if you are here, you see this is only for load, and then there's a point load here. About point load, this table we can keep here a point load if required. It's not, otherwise 0 is it. What load is where, means we have to see then that it is A and B. This is point load, the meter A, meter B, meter, that's a number, this number, and this is no, and said, and then said 333, this point load, and the B, there's no B maybe, and this is then ton meters. We find this formula, for example. This formula is NO. This is the formula. This N and this is O. We are taking these values, and P. This is P here, and this formula is there. So we are using this formula for link purpose, and also this is WA B square and WA. Like this formula is WA B square over L square, and WA square B over L square, and WA into B over L, which formula, and WL all that. And there's a moments now, how moments can come with this formula. See, this little complicated formula here. You see A96 and G96, U106, and in multiply by W96 into G132, G134, and G96. So this formula is depending on the requirement. This formula is there, and this is such seismic area I taken. If it's valid 1, it's not valid 2. So there are calculations and similar thing. And this link is there. All these links, where do they go? These links, if you go to F5 will say analysis, first of analysis, story table, history forces. These forces we are talking, then method brief and notations, and this RCS quantity, RCS, ICE, and this is story RCF, story results, story sway, and this is, I can say, story analysis. If you see analysis, let's go, this is analysis. Now, those where we calculated those forces just now, those are linked here. For example, it's linked here, right? It's linked here. Same I96, so the values by A22, A88 and U96, and this is X13, so this is from here, but this is from there. This is load, and this is load, and this is load. You can say calculate load. Same way, this is load, and from there you can see this load, and also you can see this load and this load. So these are links continuing. Every here links are continuing, and whatever load is there, if load comes here, you have to see that, you have to find how it is, and it's load here. And similarly, you see here also load. So all these here also loads, and here also loads. And for example, this value is from this to this value plus this value, and this value is there, this value and this value. So it's like that. Means it is called linking, so in this case there are links of relative stiffness and rotation contribution factors, and also load links. Then we have to calculate. Now we have to concentrate on this RCFC already considered. After getting loads into this, we have to work on this. That's very important point. How to do that. That's important. This information you have, and this information you have very well, and other information I will give you how we are taking. This is complicated. Now this portion we have, this portion we have, and this portion we have. We have to work out them. That's an important point. We have to get, for example, we work out there, and let us see what is that. This point is. So I'm trying to give you this value, my best capability. Just linking methods, which is more important for you. Means links cannot be done just in direct formula. It can be done in some design formula, and how it looks, and that's very important point. So what I'm saying, I'll let me close this file because the purpose of this file is over. So let me close this file. No need of this file now. I'm closing this file, and so this file is just so this tell now. Now better I'll give little blob to this so that you can understand little better. You see, yeah, it's little clear now for that. Now what is there? Let us see. Now we have certain formulas here. We have certain formula here, and we have to see how to. Now for example, this I have the link of this, and we have here rotation factors we copied from linked from, not copied, linked from there. And what we do now, we have to see, let's say this this is there. Now what it says, Z13 and multiplied by Z14. What does it mean? Z13 is this value, so this is load here, Z13. This is Z13, and I want to get this value and this value. Both values I want to get. So let's say Z13, Z14. This is Z13, this is sum of loads, and Z14 is this is the rotation contribution factor. So these two are multiplied here, these two are multiplied, and in this case, in this cell, these two are multiplied, we get one value, right? And here also this cycle, actually I'm calling this cycle 1. I call the cycle 1, and this is this value Z13 is same value, load value, and AA13. And where is A13? This is A13, this one. So we multiply this with this one, and answer is this one. And then we multiply this one and this one, and answer is this one, A13. So there is no other member here, this will say. So this is completion of first cycle at this joint. First cycle at this joint. This is very important point. We cannot move to other joint until we understand this. We have just started, just started calculations of forces, calculation of moments at joint number 1, or A0. You can say it is A0 joint. Beam and column are involved in this. That's why we say it's involvement of this. So this is, you can say this is A0. It's written A0. This is load here, sum of these two, and this row contribution factors here, and contribution factors from that table in beginning we see this and this multiplied by this, and we get this multiplied by this, the signs it will take automatically. So this is one cycle. Then we cannot work here, we have to jump off from here, we go there. Now it's there, you see this load is this sum of these two is here. Now okay, same thing applies here. There are three members. Now one is this this B, one is this B, one is this column. So what we do, we have already said that this is our from L13, L30. These three rotation contributions from that table we just talked to. So now what you do, this is low. Now here let us say I take this chance here. What to do? Sorry, not this one. Sorry, I'm sorry. This I'm sorry. Yeah. AG, see AG13. AG13 is load here, and then it is sum of AB14. AG13 and AB. What is AB? That's the point here. Actually, AB is something from here. When we are here, we have to pull this side because already we have calculated that one. So AG13 here, and this AG13 is this plus AG13 is this plus this one which we got here 1.588. This is AB14. So this is AB14 means this joint pulls this value here, and we sum up this, and this AF multiplied by AF13, and AF13 is here. AF13 is the rotation contribution factor. Now we go further, we get value here. Now go on to this joint. This joint, let's say, calculate this joint. L4 we say rotation contribution factor, rotation contribution, rotation. So this value we calculated. Now we reach this value at column. That one was, this was for beam, and similarly this was for beam, this was for column. Now this is for beam and this is for column. Now how we calculate? You see, we say AG13. Now AG13 is same value here. We add to this AB14, and this is AB14 here. B14, and we multiply by, because there is only opposite near one, we cannot take this for column, so we are taking this one AG13 plus AB14 into AG14. AG and 14, this is value, this is factor multiplied rotation of the factor, so we get this value. So we got this value, this value, we got this value. Now we have to go here, because there are three members, so this value we have to work out. Just this value we have to work out how to work out that's important. Now I have to work out this value. Now this is again, it says AG13 is here, and this is AB14. So we say AB14, AB is here, and 14 is here. So we take this value here and close bracket, and we say AH13. This is AH13. This is contribution factor. So we get this value. So what we got? We got this value for beam and column. We got this value and this value and this value for these three members. So one cycle of that one of this A0 joint is over, and one cycle, first cycle for B0 joint is over. Now we have to go this way. We cannot go vertically immediately. We have to go this way, and we have to reach a joint C0. This is your force. This is force of A, where AL13 plus AP13. So this is force here, means this force and this force are summed up. Now here as contribution factors, as you said, from that table L17 or L18 or whatever it is, we have to calculate again same. So we have to calculate this first. What it says, AN13. AN13, where is AN13? This is AN13 plus AI14. Here only one value, because this first cycle we are doing. So we take this value AI14, we sum up and multiply by AN13, and this is AN13. We get this value. It's gonna come out of this one. Second value we have to find. So here same way we see AN13 plus AI14, this opposite value multiplied by this one AN14, we get this value, and if you take this value, we have same thing here. We say AN13 plus AI14, that is here, and sum up into AO13, and AO13, which means AO13 is this. So we complete first cycle of this joint, first cycle of rotation contribution factors of this I think it's gone again. Again, it is gone, I think so. Oh no, yeah. I think it's gone. Video has gone. It's there. Okay, fine. So sometimes I fear, due to whatever reason, because I have to waste my time. It's already 49 or 40 minutes, around 50. So now I say we have done this cycle first, we have done this cycle first. I mean to say we have done this value, 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 we have done this value. Now we go to this joint, that is DO. So this is value here, load this, and we get this value. Now we work on this rotational factors as before. So we put this value here. Now this value same, I say AU 13 plus AP 14. Yeah, AP 14, AP is here, the remote one, distant one, AP 14 opposite one, and we sum it up and multiply by this 80 13. So we get this value. Then so we come here, we say here we have this value also, AU 13 we have here, AU 13 plus AP 14 is here, and multiply by this value, we get this value. Then we come here and we say here we have same value, AU 13 plus AP 14, and we apply. So the first cycle of this cycle is also over. Then we go to next joint here. Now here we have this value AS13 plus B13, this is A13, this is AS13, and this is AS13 plus BD13, and this is this value. Where is this? Sorry, this value AS30, AS30. Well, there's some error anyway. There's a linking. There's some error here. Well, there's another. We're talking of this now. Well, let's calculate this one. Let's calculate this. The cycle BB13 it is, and this is BB13 plus AW14, and this is AW14 and close, and BA13. This is BA13 here, and same way we get this one. We have get this one here. BB13 is here. BB13, then AP14, and then we say this is AP14 here. AP14. Means the way with which we did, we have to do this, and we have to do this, we have to complete this cycle, and we have to come back again like this, and we have to start here. For example, we are taking this AX25, this is X25, this one, and this AB25. If we get this value and these factors, we have this factor or rotation, these three factors here, because there is a column here also, there's nothing here, so these three factors we have, and then we have to find this value. This is Z24, that's 25, and Z15, Z25 here, and Z15 is this one. This is Z15 here, because value cycle is here. So we add 2, and we say we have Z26 is here, Z26 is in this direction. So this is Z26. Yeah, this is here. Yeah, it's here. So this is Z26 here. So we get this value. Then we go over there, and we find again this value Z25 plus Z15. Z15 means this value, and we multiply by A25, which is this one. A25. We have to multiply A25, and that is this one. And again, we say this cycle is complete here for this. Similarly, we have to see here A25, this one and this one. We get this value, both sum, and then we have here these factors, all four factors, and then we have to find this value, this value, and we have to find this value. Here we have four values to work out. I know A is having full member, you can say 4 members. This is start this one here. We can say this one is, how to find this one is AG, this is the low there, AG 25, and this is plus AG 15, you know where it is, AG15 is this one, AG15 here, and AB26, and AB26 is this one. So we get this value here. Once we find this value, then here also similarly we can say this value AG25 plus AG25 plus AG15, which is this value, and AB26, AB26 means this is AG26 is this value. Wait a minute, AB, this value, this value, sorry, this is for this end and then this for this end. So AB20, and we get this similarly means we have to rotate these cycles like this. Here also we have to do same thing, AB, and AB, AB, that is this one here, AB26. So we get all these four values like that, and similarly we have to link these all. Similarly we have to calculate. It's very actually very we have to do this one, we have to do this one, we have to do this one, and we have to do this one. So this is very complicated cycle. This is the first cycle to complete here. This first cycle only, we have to go to another cycle. Now we go back to same place, and because this is not same place, this is same place. So we have to find this value. That's a very important point. We have to find this value. I think I may be explaining to you this linking is very important. Without linking, you cannot do this. Even in software used for designs, this type of something, linking is done behind the scenes, and immediately it comes up. Maybe there's I am just trying to explain to you how it is done, and that's very important one. Means you should know in what way something been done in these cells. That's very important point. What way we can do, what way it can be done. That is beautiful point. What you can do. So we move back and listen now. Second cycle. Now this is second cycle here. Same thing means we have to say this Z13 here, and we have to add first in this Z13 to A14. Now what is A14? A is here. This is available first cycle. So in that first cycle has to go here, plus this value also first cycle has to go here, plus AA19. Other values AA19, AA, and this is 19. This is 19 also. Not. This is displacement factor. So like that we have to move this into AB18, 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 this value. First we have to do this portion of this. First we have to do this portion of this, and then we expand it further. And Z14 is here, and Z14 is here. This is factor and this factor. So this is second cycle. Then we have to go to other point of second cycle here and calculate similarly using first cycle value. And here if you go, this is second cycle, and this you use this value also. In this, when you go here, this value you can say AG13, and then you can say from here you can say this is AL14, and this is this value of first cycle plus AG23. This is AG23 here first cycle, and then AB15 and AB15 is so the first cycle will be added to second cycle, and this is answer. Similarly here you will do same thing, and first cycle you have to do later on. You apply this formula later on, not now, and then you can say here is second cycle again, and these three cycles are three values are over in the second cycle, and then you have to go to this again second cycle. You have to do here same whatever was done on BO, that you have to do CO. We have to get this cycle, and we have to do a cycle, add first cycle value, and then we have to get this answer. And similarly we go on this here, here and here, and also here, here and here, and we get values, and here and here. Now similarly, now this is first second cycle half. Now this again here we have to put here three members, so we have to take accordingly this one, and this one second, this second value, this first value, and this like that. This we have to find here, and we have to find here. And now we are going again second cycle. So this value of second cycle has to come here, and this has to come here, and this has to come here, and also here, because here when I say you have to take second value here, there's a four members again, and these four members again here, which is same thing you have to do for this, and for this, and also for that. And similarly second cycle here, second cycle here, second cycle here is that one, and we have to do similarly same thing here, second, 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 and second, and this one second, this one second, like this. We have to do this this analysis and this linking. And then you have to do third cycle. This is third cycle here. I mean, I have tried to limit to 3 cycles. You can take more, because if you take more cycles, you have to change complete architecture of this. So let us see how it works. It's really something, maybe you may not get it immediately if you are not an engineer, but it's not difficult. We are saying we are talking of this. Let us see one thing, how Z13 plus AE15. Where is AE15? AE15 is second cycle value. Then Z22 this second cycle this first Z22 is here. Z22 second cycle value, and then AA19, and that's another formula. And Z14 is here, double by this. Then you go to this third cycle. Now go to this one. You will find the same Z13 plus AE15. AE15 is first second cycle, and Z22 is here. Z22 is here. That is Z22. This is here, second cycle. So you got this third cycle completed. So this value is given to you. This value you achieve. Here you start this third cycle. So you get AG13 plus AL15. This is AL15 means this value, second cycle, and you can see AG22, same thing here, cycle, and you get this value. Similarly, you got this value. You had once here, and you take previous one. So you go to this cycle, and then this cycle, and then this cycle, and like that. All here you have to do, then you have to do here, and then do here, and then you have to do here, then here, and then here, and you have to do here and here. So you got this third cycle of upper portion over. Then you go to same thing. You do here, you have to do here, and you have to do here. So secondly included, and similarly same thing here. For example, this is third one value, this is another value, this is value, this is another value, and this is another value. Here complete 4 members. So you can see here you increase this one. You can see it's increasing AG25, AB28, AG17, AI27, and this is cycle, and then there's another formula in that. We'll see later on. Multiply the AF25, and this is AF25, and in this case there is AF AG25, same value, and it is here. In this case AH25, and here in this case is AG24. So C cycle third, and also with 4 members, and same thing here. This value, this value, this value, and this value have to work out, and also here you have to work out this value, this value, this value, and this value.